Join me as we step back in time to a period when the world feared a new ice age was imminent and uncover the fascinating story behind the global cooling theory. The chill of the morning air bites at my skin as I stand at the edge of a vast, frozen landscape. The sun, a distant and muted orb, barely rises above the horizon, casting a pale light that barely penetrates the dense, white fog. This is not a scene from a distant future. It was a real fear that gripped the world in the 1970s. A fear that the Earth was not warming, but cooling, and that a new ice age was on the horizon. Today, we will journey through this chilling chapter of history, exploring the science, the media, and the public reaction that shaped our understanding of climate change. In the early 1970s, the world was in a state of flux. The Cold War was at its height, technological advancements were reshaping society, and environmental concerns were beginning to take center stage. It was against this backdrop that a new fear emerged, a fear that the Earth was cooling, not warming. The idea was not just a fringe theory, it was a widespread concern that made headlines, sparked public debate, and even influenced scientific research. But how did this belief come to be, and why did it fade so quickly? The story begins with the climate data of the time. From the 1940s to the early 1970s, global temperatures showed a modest cooling trend. This cooling was small, but it was significant enough to catch the attention of scientists. After all, the early 20th century had seen a period of warming, and the shift to cooling seemed to contradict the prevailing scientific understanding. The cooling trend was not uniform, it varied by region and season, but it was enough to raise questions about the direction of Earth's climate. One of the primary drivers of the global cooling theory was the concern over aerosol pollution. Aerosols are tiny particles that can come from natural sources like volcanic eruptions or human activities like industrial processes. These particles can reflect sunlight back into space, increasing the Earth's albedo, reflectivity, and potentially leading to cooling. By the 1970s, industrial activities were at an all-time high, and the levels of aerosols in the atmosphere were rising. Scientists began to hypothesize that these pollutants could be the cause of the observed cooling trend. The media played a significant role in amplifying these concerns. Headlines warning of an impending ice age and widespread climatic disruption became common. Stories of food shortages, crop failures, and catastrophic weather events were splashed across newspapers and magazines. The media's coverage was often dramatic and sensational, but it captured the public's attention and fueled a sense of urgency. People began to take notice, and the fear of global cooling became a part of the cultural zeitgeist. However, the scientific community was not entirely convinced by the global cooling theory. While some scientists were concerned about the cooling trend and the potential impacts of aerosol pollution, the majority of the scientific literature continued to focus on the greenhouse effect and the long-term warming potential of greenhouse gases. The idea that the Earth was cooling was a minority opinion, but it gained traction in the public eye due to its dramatic nature and the media's amplification. Another factor contributing to the belief in global cooling was the study of natural climate variability. Scientists were aware that the Earth's climate had undergone significant changes in the past, driven by factors such as volcanic eruptions, changes in solar activity, and long-term shifts in Earth's orbit and axial tilt. Some researchers hypothesized that the Earth might be entering a new phase of natural cooling, similar to the Little Ice Age that occurred a few centuries earlier. While these ideas were speculative, they added to the growing concern about the future of the planet's climate. One of the most intriguing hypotheses was the role of Milankovitch cycles. These cycles refer to long-term changes in Earth's orbit and axial tilt that can influence the distribution of solar energy across the planet. Some scientists suggested that we might be at the beginning of a cycle that would lead to cooling. However, this hypothesis was based on limited data and was not widely accepted within the scientific community. Another area of study was changes in solar radiation. The Maunder minimum, a period of reduced solar activity in the 17th century, was associated with cooler temperatures. Some researchers speculated that a similar reduction in solar output might be occurring, potentially leading to global cooling. However, this theory was also speculative and lacked strong empirical support. As the 1970s progressed, the scientific consensus began to shift. By the late 1970s and early 1980s, the cooling trend that had sparked the initial concern began to reverse. Global temperatures were on the rise, and the trend has continued to this day. This reversal was the first major blow to the global cooling theory. Scientists were now faced with a new and pressing concern: global warming. The 1980s and 1990s saw significant advancements in climate modeling. Thanks to the development of powerful computers, scientists could simulate the impacts of various factors on global temperatures with greater accuracy. These models consistently showed that the warming effect of increased greenhouse gases far outweighed the temporary cooling effects of aerosols and other factors. The more data scientists gathered, the more evident it became that the brief 30-year cooling period was an anomaly in the context of long-term climate trends. Long-term climate data, ice core samples, tree rings, and historical records all painted a clearer picture of Earth's climate history. This comprehensive data set showed that the observed cooling was a blip, not a long-term trend. By the late 1980s and early 1990s, major scientific organizations, including the Intergovernmental Panel on Climate Change, IPCC, were issuing reports that clearly stated that human activities, particularly the emission of greenhouse gases, were the primary drivers of recent climate change. The discrediting of the global cooling theory was a testament to the scientific method and the ongoing process of scientific discovery. It showed that even well-intentioned hypotheses can be flawed and that new data and better models can lead to a more accurate understanding of complex systems. However, the legacy of the global cooling theory is far from over. Today, the theory is often used by climate change deniers to cast doubt on the science of global warming. They point to the media hype of the 1970s as evidence that climate scientists are unreliable and that the current concerns about global warming are similarly overblown. Despite its shortcomings, the global cooling theory did contribute to our understanding of climate science. It highlighted the complex interplay of natural and human factors in the Earth's climate system and underscored the importance of aerosols in climate modeling. The theory also brought attention to the need for better monitoring and data collection, which has been crucial in advancing our understanding of climate change. But the story of global cooling also serves as a cautionary tale. It demonstrates how scientific data can be manipulated and misinterpreted by the media and by those with vested interests. It shows how fear and sensationalism can overshadow the nuanced and often complex nature of scientific research. The media's role in amplifying the global cooling theory has been a double-edged sword, both raising awareness of climate issues and contributing to misunderstanding and misinformation. As we stand here in the chill of the morning air, it is clear that the story of global cooling is not just a chapter in the history of climate science. It is a reminder of the ongoing struggle to understand and address the complex challenges of our changing planet. It is a story of human curiosity, scientific discovery, and the ever-present need for critical thinking and skepticism. The fear of a new ice age may have been unfounded, but the lessons it teaches us about the nature of science and the power of media remain as relevant today as they were in the 1970s. The Earth's climate is a vast and intricate system, and our understanding of it continues to evolve. As we move forward, let us carry with us the lessons of the past, the importance of rigorous scientific inquiry, the need for accurate and responsible media coverage, and the recognition that the challenges of climate change are real and require our collective attention and action. What do you think are the most important lessons we can learn from the global cooling theory of the 1970s? How can we ensure that our understanding of climate science remains grounded in rigorous research and responsible communication? Share your thoughts in the comments below, and don't forget to like and subscribe for more immersive journeys through the fascinating history of our planet.